Okay, happy Monday. So let me see what we can go. All right. Okay, so like I said, Derek, there's multiple tenants in this building, and the common areas for lights and receptacles and heating will be fed from a separate panel, which is backed up by a generator. So this is what we're going to be doing. They call them special circuits, owner circuits, because I want to remind you, we don't have these Adam in our building, these special circuits, because the building that we have is one tenant, owned and operated by one tenant, so we don't have to have a special panel for the house or house panel for the common loads. Okay, what we need to talk about, guys, is a couple of things. There are in this building, Derek, there are parking lot lights, perimeter lights, signs that will be lit and powered and lit and controlled by the owner panel. So we'll talk about the timers, a few things about the timers and photocell. You guys remember the photocell that you're using? Same photocells and the same timers, Adam, that we're going to be using for our project, the timers and the photocells. Controlling the common lighting for the parking lot and the perimeter lights and the building lights. In this building, they decided to use electrical boilers, guys. We use here natural gas, so we don't have to worry too much. In our project, Adam, you guys remember that natural gas control circuit, boiler control circuit? That's all what we did because we have natural gas. We're burning natural gas in our project. We don't have to worry about electrical circuits for the boilers. In the project in the book, guys, they're using electrical boilers, so we have to power the boiler as well as control it. Does that make sense? Now they're powering the boiler here. And then the owner, because we don't want to flood our buildings in Minnesota, you guys have seen some pumps. There's in the bottom of that building, it's a two-story building with a basement. They have a sump pump that's supposed to operate up on the flooding. Any flooding that happens in the area or any water leaking into that basement is supposed to operate. So we'll talk about this one. Okay, so these are the common things, guys, that's going to be. So we have lights, Derek, we have lights, and we have heating, and we have pumps that are shared between all the tenants and need to be powered. Does that make sense, guys? So we'll talk a little bit about these things. Okay, 3 circuits served. We have also we have an elevator equipment that need to be powered. So we have a circuit that's going to the elevator. You can't charge the elevator circuit to Karen's tenant, Karen, right? Because she is not the only one who's using it. So that's a common area. Heating and cooling, especially heating. So here's another heating, lighting in common areas or public areas, they call it. All these loads, so I have 1 type of load, 2 types of loads, 3 types of loads, with a couple of other receptacles, guys. They will be fed from a common panel, house panel. I cannot emphasize, common panel, house panel. We did this one in the residential project. Do you guys remember that, the residential project? Because we cannot charge them to the tenants. So we have to have a separate panel with a separate meter to charge them. Okay. And also we have an optional standby power system, guys, that's applied. An optional standby power system. Optional standby power system. So in order for the owner decided to put some of these loads, guys, on an optional standby power system, meaning a generator. If all these loads will be backed up by a generator, so up on the loss of power, the owner panel will be energized by a generator. It is not, I don't think they listed it as an emergency generator. It could be also listed depending how if it comes within 10 seconds, it becomes an emergency generator. That's the only difference. And it's backing up the power in the common areas. Okay, the first circuit coming between all the tenants, guys, it's called the lighting circuit. We talked about lighting circuits. Circuits that it's the owner responsibility. It's the owner responsibility to lit all the bathrooms, Adam. Don't you think so? All the hallways, the entrance and the exits to the buildings, the parking lot, the perimeter of the building. It's a multi-tenant building, remember. So the owner will lit all these lights. And based on all these lights, I want to remind you guys, there's hallways, there's bathrooms, and there's perimeter lights, and there's also parking lot. Exactly like ours, Derek, except exactly the same like ours, except they're going to be fit from a panel that's called owner panel. That's all. Okay, how do they control them? Here's how, I don't think you can get away probably with it right now. continuous operation. So you know what they did, guys? Some lights, they turn them, Adam, they just put them in a circuit and turn them on. You can't turn them off. They are on 24/7. You're going to see which circuit. They just that used to be a common practice and still some common practice, guys. Typically, stairways, they put them on and they leave them on for security and services and what's not. So they don't even switch them at all. They stay 24/7. That's one way of controlling the lights. The other way is manual control. So the second way is they put switches on them. Typically, bathrooms in this building, you will see which one of them has manual control. The second one is automatic control. Automatic control, guys, the sump pump, for example, or certain lights, which we will see. Certain lights, you can put them on automatic control. Timer, parking lot, and what's not. 4 can be on a timer, turn it on and off based on a certain time of the day. Photo cell, number 5, typically parking lot and what's not, you can put them in photo cell. So turn them on and off based on the existence of light or the absence of light. And the last one is exit signs, which they will be lit at all times, backed up by batteries. Can I get you guys to give me a thumbs up, chat? We fully understand that these are the lighting loads in the building and these are the way they control it. These are, guys, common ways of controlling the lighting in a commercial building. Any light. It's not just the owner of lights, any light. So let's go here and see which one is in continuous operation. So Adam, here's a continuous operation, stairways, in the second floor for the commercial. Remember, we're talking about this commercial building. So the stairways, they're having them in continuous operation. So how do you do that, Adam? If you were to do this in our project in Revit, you know what you do? You just circuit it and you don't switch it. Continuous operation, 24/7. So the stairway, typically, power to these luminaires supplied directly from the owner panel. Is you just take a circuit breaker and you put it on a light and let it roll. 20 amp circuit, let it roll. No control whatsoever, 24/7. With the energy code, guys, you might not get away with all of it, but remember, lights in the building, you don't want the building to be too dark too. So sometimes they just leave all night 1 or 2 fixtures in the hallways to make it not ghosty looking. So that's exactly a good example. For security reasons inside the hall, the stairways, they want the stairways to be lit at all times. Security as well as safety. Can I have thumbs up, Chad? We fully understand. We did not do this in our project. We put them on a timer and we can sweep them. We can leave them on if we want to because we have them on a timer. Okay, manual switch. The manual switch, guys, in the second floor, the corridors in the second, remember, we're in this building, and the utility as well as the toilet. Now, these locations, all the hallways, the corridors, as well as the utility room, as well as the toilets, they put them in manual switches. A manual switch could be high voltage or low voltage like this one, guys. You walk into the bathroom, you turn it on and off. Now, for us, Karen, we put these on occupancy sensor. Remember that? Occupancy sensor. The corridors, we put them on switches, and the utility room, we also put them in switches. Any comments, guys? Any questions? So manual control assigned to the corridors, utility room, and toilets. I would say other than toilets, probably now to meet the energy code, you almost have to put all these on some type of a timer or occupancy sensor, what's not. Automatic control. The automatic control, I know the sump pump, I know it's not part of your lighting system here, but the sump pump is an example of operation automatic control. So it has a floating switch, no human intervention is needed for automatic control, guys. So what the sump pump sees, if it sees certain water in that little hole that sump pump floating switch, floating ball is sitting, if it sees, depending on if there's water, it will trigger a mechanism that starts the sump pump without you and I interfering with it. That's not lighting, I can't emphasize, not lighting. Timed control, they did the time control, they did an astronomical clock located near the owner panel, and they did them, guys, for the luminaires at the entrance of the building. There's some luminaires at the entrance of the building, and they assigned right at the entrance, big luminaires, they assigned an astronomical clock. So turn it on at a certain time, off at 6 o'clock in the morning, and on at 6 o'clock p.m., on, off by 6 a.m. Any comments, or they can turn them off, actually start them on at 6 p.m. and turn them off at 10 or 12, depending how you will control. These are the entrance, luminaire at the entrance of the commercial building. Any comments? Astronomical clock, guys. A clock receives its signals from satellites and what's not, and coordinate like any other clocks. You can set it up for, and it adjusts itself. Remember that, Derek, we talked about time saving and what's not. It's all adjusted. So all what you have to do is set the turn off, turn on, off time, and it will readjust for time saving. Any comments, any questions? All fed from the owner panel. Remember, all these are common loads fed from the owner panel. So that's the time. The reason why I go over this one, Adam, it's ideas, guys, for you ideas to design. Because the building that we have, I can't emphasize, it's one tenant building. So it's slightly different than a multi-tenant building. Here's a multi-tenant building. So remember, every time you see a multi-tenant, remember what's the house panel or the common panel. Here's the time control, how the time control works, guys. Well, there's so many ways of doing it. So you have the clock. You can power your clock here, and you power your light. So you bring a circuit to your timer here. When this times kicks in, it closes this contact. So this will drive a contact here to close, and all your lights are on. When it reaches another, it keeps going, it clicks another switch, it opens it. So it takes it, say, let's just say we want to turn it on at 6 p.m. We'll go on, and at 11 p.m. when we want it off. That's enough for that sign, for the light in the front of the building. We will have perimeter lights to stay on for security and what's not. Depending on what you want to do with it, if you want to leave it on all night, we'll turn it off at a.m. for security. Any comments, any questions how this works, guys? Any comments, any questions? Typically, this circuit option standby, this circuit is 1. That circuit, you bring the circuit to the timer, you take it out of the timer, Adam, and into the circuit. So the way we typically circuit it, you bring, here's one way, here's a 20 amp circuit, you bring it here to a timer. Out of the timer, you go to your light or lights, and then from the other side, you have to bring your neutral with it, right? And that's how we typically wire it, guys. Does that make sense? So what I want to emphasize, you guys are doing the site today for chat, right? When you go to Revit, Adam, this is exactly what you're going to do. You're going to lay out your fixture. You're going to put a timer 1 in the mechanical room, and you're going to circuit this fixture from circuit number, I don't know, number, say, 24. And then, so now it's circuited. This is fixture W, and it's going to be switch fixture W. The circuit that's going to circuit it is 24, and the timer that's going to switch it is time 1. And label it with timer 1, fixture W. Let's say we named it fixture W. 24 is the circuit, and timer 1. Does that make sense? Exactly like we did in the floor plan, right? Exactly like we did in the floor plan. Exactly the same thing. Except we're going to do a timer this time for the parking lot. That's exactly what the timer is, guys. Drive these to turn them on and off. You can have multiple contacts in it. I'll show you in a second here. Okay, photocell. Now, our speaker, Keith, guys, talk about the photocell. The photocell, they decided, remember, this is a different project than ours, and we could do the same thing. Luminaire is located on the exterior of the building. The exterior luminaires, they put them on a photocell. A tiny little device sits right by the fixture, guys. Drive all these fixtures. Drive them on and off based on the absence and existence of light. How does it do? Photocell control consists of a lighting sensitive, light sensitive cell. That's how you sense, is there light or absence of light. Then when it gets you that tiny little current, Karen, tomorrow our speakers will talk about these guys too. So first you sense the absence, you sense that there's light or the absence of light. When you sense the absence of light, guys, it creates a tiny little current. That little current is not enough atom to drive. So what they do is they amplify that current. So multiply. If the current is that big, can you see that? Scale it up, amplify it. To increase the signal until it's sufficient enough to operate the relay. So here's how it goes. First you sense, then you amplify the current, then the amplified current will operate the relay. The minute that you operate the relay will drive, guys. Here's a relay. relay contact. So the relay now, the relay is getting a signal from the occupant, from the photocell, and the photocell will drive this contact to close. Any comments, any questions? Any comments, any questions? So light sensing cell, it senses the absence of, if there's light, guys, or if there's no light, the mechanism will trigger a current sensing, amplify it, and drive a relay by it. Any comments, any questions? It's exactly, almost, well, photocell, it's almost the same principle as motion occupancy sensor, except occupancy sensor is looking, guys, at motion. It senses motion, and it senses motion in the area. So if somebody moves, it turns on. If nobody moves for a certain amount of time, it turns off. Okay, so that we have our photocell. Now for our parking lot atom, we're not going to put them in a photocell. We're going to put them in a timer. We decide. You can put them in a photocell. Then you have to just put a photocell. Either one photocell drives all the parking lot, all of them, or one photocell with every fixture. Okay, here's the photocell. Exit signs. Karen, Adam, you did these. Karen and Derek and Matt, my friend is not here. We're going to have exit signs. Where do you want to put your exit signs? Exit signs, guys, are ways of communicating with the public so they can safely exit your building upon an emergency condition, right? So you have an emergency condition and you need the people, the public, to evacuate your building. So they need to be able, without your direction, to find the exits, right? For life safety codes, as well as building codes, and all these will force you to insert all these exit signs. Where do you need them? You need them on you need them, guys, on the egress path. You need them wherever the egress path goes to show the signs. Hallways is a good example of them. Every exit signs will have the egress door will have a sign that says exit on it. For the building, guys, that we're in, I'll show you where we're going to put them. I have an egress path for you. Controlled by local code, again, building codes and life safety codes, and let's not control them. You have to have a battery backup with them. They all come with a battery backup, guys. It's a sign that says exit in it. You've seen it all the time, green LEDs and what's not. Must be connected ahead of a local switch. Here's how they do them, Adam. Here's the circuit, look at this. Here's the circuit feeding this area, 20 amp. Here's the switch that switch this circuit. This is my switch. And here's the light in the room. And here's my room, right? Here's my light and here's my room. Now I need to have an exit. See, I need an exit sign right here. Can you guys see that? So now you can, remember, they have a battery inside it. There is a battery in it. So what you do is you come from this side, the line side, and you feed it. Everybody see that? The exit sign here, my exit sign that has a battery, you come from the line side of the switch and you feed it. Same thing like emergency light, guys. The emergency light, if you have that bug eyes that you're going to be putting here, you come from this side and you feed it. Now the smarter than Chad, guys, can have, what if we combine this one and this one, the emergency light with the exit signs with a combo? And you, Adam, drop a few of them, right? So what they do, they can put little bug eyes here and you feed them from the same location. Ahead of the switch, because you don't want to switch them. So what happened, Karen, is if somebody, Chad, goes and tamper with this, turn this circuit breaker off, it accidentally, intentionally, a storm hit the transmission line, we have no power. Every time the power is off in this circuit, these two lights will go on. They call them locally because the power accidentally, somebody tripped the circuit breaker off, or globally, a transmission line got hit down and you lost power. That's how emergency lights and exit signs work. Any comments, any questions? That's why I want to go over this one, guys, because it's directly related to what we're going to be doing. What we have done last week and what we're doing this week too. Okay, a few things about the sump pump and what does it do for living. Sump pump, guys, is supposed to remove the water upon it exits a building from a location that's not approved. For example, I don't know about sewage lines, water main breaking inside the building, flooding, and what's not. So You've seen them, guys, especially in Minnesota. We have tons of them there in the basement. A lot of people have them, have a little hole. They put that little device inside it, and the sump pump, if it's submersible or non-submersible sump pump, and if it fills, it pumps this water outside and keeps operating up on that floating switch. It is connected to the emergency panel. Well, it's when you say emergency panel, it has to come up within 10 seconds, guys. But typically, if you have some pump in a commercial building, it's legally required standby system, and it has to be backed up by a generator, and the generator have to come up within 10 seconds if it's emergency, or 60 seconds if it's critical or legally required. So the owner, it will be fit from the owner panel, which is backed up by a generator, and the generator that can be standby generator. If we turn it, if it comes up within 10 seconds, it qualifies as an emergency source of power. Floating switch, you guys, anybody have wired these? You've seen them? Floating switch, the water starts getting up and up here. It pushes this baby up. As it pushes this baby, guys, it closes a contact. And that now my pump is pumping, right? Then the water starts going down, 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 down. That ball goes down, right? And then it to a certain level. You have to have a range, right? You allow it to pump all the way until it reaches almost the bottom and stops. And then, so what they do is they don't make it, they have a range, guys, for it. They don't, otherwise it will be turned on and off, on and off. So there is a range where it operates. So if it's, here's an on, it has, here's my off. When it reaches this point is off. When it reaches this point is on. So it allows this range for it to operate. Any comments, any questions? So it fills all this area. So when you start on, it keeps until it empties it to this point. It stops. Then it keeps waiting, waiting until it fills up to this point, and it turns it on again. Can you guys understand? Otherwise, it will be on and off all the time. So you have to have range when they set them up. Okay, sump pump, protected by a manual controller starter and controlled by a floating switch. They have a magnetic controller, guys. A floating switch is turning on and off. Here's a magnetic controller. Here's, it looks like this. Here's a contact, and there's a floating switch. My floating switch is bringing voltage to this voltage, say 120 volt to this coil. When this coil is energized, bang! Now that thing will close. When the floating switch opens, it opens a control circuit. So what controls the control circuit is a floating switch. Okay, so pushes, and this is just about the mechanism. Pushes against a small integral switch within the submersible pump. So that's inside it, the floating switch they designed it, guys. It pushes certain mechanism to turn it on and off, turn the contact. Water heaters and space heating. They have also, now remember, we're talking about the public spaces. In all the public, can you see the word public restrooms? They do have a water heater right there to get you domestic water. That's how they design it. So they got 120 20 amp circuit, guys, to feed a water heater for the male and the female bathroom, so they can have hot water, instant hot water. Also, because they don't want them to be cold as they do their business in the bathrooms, what they do in the public bathrooms in this building, they have also space heaters. They have a heating element, an electrical heating element with a fan that forces the heat. This is, guys, give you ideas, Derek. If you are getting into a strip mall and you need to wire it, you know, or something, here's an idea. So instead of having bringing the heat, the central heat to the building, to the bathrooms, you can, because you don't need a lot of heat there, you can have a specific heating elements in all the bathrooms as well as the water. So these are typically, guys, for multi-occupancy buildings owned by one operator, so to get you a cheaper way of doing business. What's the more expensive way? To have a domestic water heater. You heat the water and circulate that hot water into wherever you need hot water. There are two types of hot waters carried in any building. Something called domestic hot water. That's for you and I to shower with and wash our hands. The other one is for heating the building. Hot water, closed loop hot water. They use it to heat the building. Everybody understand? It took me a while to understand the difference. These are two different piping systems. They don't interfere with each other. So, all right. So elevator, we have a circuit that feeds the elevator, guys. The elevator does not have a machine room. Machine roomless elevator. Um, Lifting mechanism, feeder supply. You have a circuit that feeds the elevator. The elevator, guys, is a pump, so you size exactly like a motor. It needs a disconnect that you typically have a circuit breaker or a fuse disconnect with inside. So right in here, you would typically fuse disconnect right next to the elevator, a fuse disconnect like next to the elevator. And also for maintenance, Adam, inside the elevator, you need light and fan. So you need a circuit for the car. If you guys walk into our elevator right here, what do you see? You have a light, fan, and a light inside the elevator. So they give a 20 amp circuit typically for the light inside the car, the elevator car, a 20 amp circuit for the fan inside the elevator. And in the machine room, they typically have a 20 amp circuit that feeds GFCI receptacles. So these are dedicated to the elevator. So be aware, if you have an elevator, you have to have the following. Number one, a circuit to feed the elevator. Number two, a circuit for the light and the receptacles in the elevator room or the machine room. And number one, number two, number three, you need to have a circuit to feed the fan inside the elevator car itself, and another circuit, guys, for the light inside the elevator. Does that make sense? So all these come typically from a pan. What they do, guys, for elevators, they have a feeder and have a panel, an elevator panel, and they feed the light, the receptacle, everything for that elevator from that little panel. That's what they do with elevators. But they typically need a GFCI receptacles, guys, in the machine room. They need a circuit, dedicated circuit for that receptacles. They need light, a circuit for the lights, what we do in that machine room, a circuit for the car itself that goes up and down for the fan as well as for the lights. So be aware of that one. The last thing that they have in this building, guys, is remember, there's domestic water for washing and showering and what's not, and there is closed loop hot water to heat the building. Okay, so this particular one is my electrically heated boiler. My electrically heated boiler. They are burning electricity. Look, I don't know how many of you guys look at this building. Look at this, 200 kW. You know what 200 kW is? You know what 200 kW? 200 kW, to give you an idea, these are literally 20 homes. Like your house will take on average 10 kW. So that's 10 kW, 20 homes, equivalent to 20 homes. Power is just to heat that building, that boiler. Can you guys see the gravity of that one? 20 homes, 20 standalone dwellings on average. That boiler has the power of 20 in a commercial building. Do you guys see the gravity of that boy? Big boy. So 200 kW. It's on and externally except for external control wiring. So it's all pre-wired, guys. There's some external sensor you have to bring to it. Here's how it works. You have to wire an external heat sensor. And what they do for them, did you guys tour them, Woody? I don't know if you've done tour with our electrician's not here anymore. But what they do is they have a sensor outdoor. When the temperature outdoor reaches 65, it starts the boiler. Otherwise, the boiler will sit there. When it's 75 outside, you want your boiler. Now remember, this is boiler for heating, not boiler for domestic water. Boiler for heating. Do you want to heat the building when it's 90 degrees outside? So this sensor will control the boiler externally first. So do I even want to, is it cold outside to start that baby or not? Otherwise, the boiler is blind. It doesn't have any eyes, right? So you need to sense what's going on outside. When it's 365, guys, it starts the boiler. Now the boiler is up and running. Doesn't mean it's heating. It's just up and running. It has enough juice in it to heat if needed. Any comments, guys, about this external sensor that interface with that boiler? So, okay, electrical boiler. So when the heat sensor closes, now we have 65. The boiler starts cooking water, heating water. Now we start heating water. And then it waits, though. It starts heating water temperature. It raises the water temperature, and it's ready to deliver heat when any zone asks for it. So they heat. Here's how they do it. One way of doing it. They heat the water, guys. They heat the water with a big boiler. They circulate the water with pumps. So suppose this is Chad Curtis' engineering office right here. And I'm going to have a thermostat right on the wall. I like it warm and cozy, and I'm going to set it at 95. Right? So you set that thermostat at 95. The pump associated with Chad Curtis' place will pump enough hot water to the radiators in that room. Now you have a thermostat that you can set. That thermostat will control the pump. It keeps pumping hot water until the temperature in your room reach 95. And I'm just being ridiculous here by 95. When it reaches 95, guys, it turn it off. So they have radiators that can heat either radiators, or you can have like air handling unit system where you can blow air into it and whatnot. I think in this way they're using radiators. How do you wire it? It's the boiler, guys, is called fixed electric heating element. It's continuous load. Very simple. You take a circuit breaker, and here's my boiler. Here's my boiler. Look how easy that is. You need a disconnect. So how do you size the overcurrent protection device? This is your feeder or branch circuit. How do you size this one? 1.25. How do you size the conductor? 1.25. How do you size the disconnect? 1.25. How do you size what else? That's it. So you size the conductor, oh yeah, three phase or single phase. And this one was three phase. You can't power this one. Can you power 20 homes from? I guess you can from single phase, but this particular one is three phase system. So how do you size the atom? Very simple. Take the full load amp of that boiler, multiply by 1.25, size your overcurrent protection device, your disconnect, as well as your conductors. Done. So that's as simple as it's continuous load. This is the circulating pump, guys. So here's Chad's. Let's just say this is Adam. Let's instead of picking on Chad, let's pick on Adam. Huh? Oops, Adam, you're here. Adam's office is sitting here. Adam likes it cozy. He wants to set this thermostat at 80 Fahrenheit, really warm. So when you set it 30 when it kicks in, closes this contact, this relay will energize and close this contact. Now the circulating pump start taking water all the way to Adam's office, circulating the water to Adam's office. Can you guys see that? The hot water. And it radiates heat. Any comments, any question how this works? They radiate heat. So that thermostat in your room is controlling a pump, a circulating pump that's sitting somewhere else, And that pump have pipes, huge pipes that send the hot water to radiators. It radiates the heat into your area. Now you're cozy and warm. And then when you reach the sit temperature, it set it down. And of course, there's tolerance. Like thermostat and dwellings, you have a tolerance in it. Any comments, any questions how this works? Very simple, very easy, guys. The sump pump, look at your sump pump here. Your pump, it could be 15 amp or 20 amp on the pump. So smaller pumps. Okay, we talked about, guys, you need a disconnect means. The disconnect shall be installed to disconnect all ungrounded conductor. 1.25 sizing here. Disconnect means shall be size 125. Disconnect means shall be within sight or capable of being locked in the open position. So you put the disconnect within sight of the boiler. The branch circuit, same thing, guys. 1.25. Remember how I drew that one here for you? So you overcome friction device, disconnect conductor, all 1.25 when you size them. Very easy, very simple. Overcome friction device, we speak of the devil. There you go, 1.25. Which article talks about the fixed boiler, heating boiler? 424. Article 424, if you go there, it will tell you exactly 1.25 is that magic number. And anybody knows why 1.25, guys? Continuous load. So that's it. Very easy, very simple. Fixed electric space heating equipment. And the electric resistance boiler type, this is the part, which would that be? Part 7. Part 7 of it. In particular, talk about resistance. What they do, guys, they have resistance inside a big tank, and they burn these resistance, electricity, and it boils water. And when they boil the water, now we have big tank full of hot water, and you circulate the hot water to radiators. Radiators Mechanical radiators will radiate the heat in. That's one way of doing it. The other way, Adam, later on, next project, they send these hot water into something called air handling unit. Like in our building, the air handling unit now, it's nothing but pipes full of hot water and big blower, fan, blows air right through the hot water, the coils, mechanical coils. They're full of hot water. So if you blow air through a coil that's hot, what do you think you're going to get from the other end? Hot air. That's how you get hot air in a commercial building. We will go over that one, guys, in another chapter too. So how does it work? Thermostat have to be located. Look at this one. Every occupants, building occupants have their own thermostat that drives their own pump. Their own circulating pump will be driven by their own thermostat. And then it just sends the hot water to that building, and now you are hot and cozy. How about cooling it? Didn't say anything about cooling. You have to have your air conditioning to cool you. This is just to heat you. From the circulating pump, guys, since they have a generator, they're supplying them from an emergency panel or regularly required standby system. If the utility fails, what happens if the utility fails and you have hot water? You have water and there's no heat. It will freeze. So the smarter than Chad, what they do is they have an emergency generator, guys, sitting there. If it fails, if the building fails, these pumps, they have 1 or 2 pumps, guys, on the emergency system, just sits there and circulate the water so it doesn't freeze until the electricity comes. Now remember, this is not heating the building. This is just circulating the water. Just 1 or 2 pumps circulating the water. Circulate. No heat in the building, just circulate the water. And the water will have antifreeze too in it. Mind it will have an antifreeze. And it just keeps circulate, so it doesn't freeze and bust the system. Until, now if you want to run the boiler, you have to have a bigger, fatter generator. A freeze could damage the boiler and the piping. Why? Imagine if you don't do that one, you will damage your boiler. You have to have a way. In Minnesota, guys, it's freezing. We lose the power here, right? Now we have a boiler and pipes full of water. What's going to happen to them in two days? It will completely freeze and bust the whole system. So you have to have some means of. We have generator right now that circulates certain pumps. You can't run the boiler itself. Well, we have natural gas here, so we don't worry too much about it. You could run the natural gas from the generator, right? But all what you need is just a control circuit. But you can't run the pumps though. Okay, this is how it works, guys. All this is 3-phase. Look at that. We're bringing 3-phase, 2 sets of 500 kcm to this boiler. The way they do it, guys, if you need more heat, they start closing contacts. Certain contacts close at a certain time will give you more heat. That's how they run these and they're grouped. It looks like listed 75 amps each one of them. Fuses that fuse them. So these heating elements, instead of having one heating element, they have multiple of them, and they turn them on and off based on the need. If you need more hot water, a lot of hot water, they turn them all on. If you need just a little bit of hot water, guys, they turn a few of them on. Does that make sense? Now all this is happening inside the hot water. You guys wouldn't see it. And I can't emphasize, look at this. 200, 208, 3-phase, 3-wire system. No neutral. Completely 3-phase. Adam, does it make sense? Okay, so that's very few guys of you will see that. So that's what I have for you guys. So we have our elevator. I have a few pictures I'm going to show you. And then I'm done with that. Okay, so let's go to, here's where we talked about here's the bathroom, guys. I don't know if you see the bathroom here. Here's your bathroom light over here. The bathroom lights will be fed from the owner equipment panel. All these lights in the hallway, common hallway, will be fed from the owner equipment lights. The elevator, we talked about the elevator here, guys, will be fed elevator panel, elevator control. All these will be fed from the generator as well as from the owner equipment panel. Space heat in the bathrooms, and there should be a boiler somewhere. I think that one, circuit 5, is the electrical boiler, special boiler. That's what they show them, how they show them, guys, inside the building. Again, we're just focusing on the common area. The other one I want to show. Okay, we talked about this one, guys, how it works. This is the photocell. The way the photocell, guys, works. So it senses that there is no light. So in this case, closes this contact. Now your light goes on. So like I said, let's say 6 p.m. To this is on, and 6 a.m. off. So it will be set internally. When it sees that there's no light in here, turns it on, stays on until it sees light again at 6 p.m. and turns off. That's your photocell typically used on lighting fixtures. Any comments, any questions? You can use a timer to drive it. You can use anything you want. So that's your photocell. We talked about, guys, the floating switch. Here's a way of a floating switch works. This is a line voltage floating switch that controls, you bring the power into the disconnect and overload, guys, directly. And then there's a floating line voltage floating switch that turns the power on and off. Very, very interesting. So that's your control for the sump pump. This is your heater. I want to bring to your attention, guys, your heater. The first thing, Adam, here's my this is my 200 kW heater. This is your control mechanism. Now, outside temperature is 65 degrees Fahrenheit. This will close. Now, low water cutoff. This is for safety. If there is no water in the pipe system, you're not going to heat it and explode it, right? So that will make sure it doesn't work unless you have water. Boiler temperature control, that will control how much temperature you want it to reach. And high limit control, that will open you if you, before you change, Karen, before you keep boiling the water until it turns into steam, there is a high limit temperature that stops the process from happening. Any comments, any questions? And there's also an on-off switch. You can turn it on and control it. That's your, Adam, do you remember that 20 amp circuit that you did for the boiler with us? That's what 20 amp circuit does for a gas boiler. Except this is happening to electrical boiler. Same thing. Here's 20 amp. It just feeds a controller circuit. This is, again, these are safety. Oops, this is safety. This is safety. This is my control. And this is also my control. And this is also my control. So two of them are safety devices and the rest are control devices. That's how you turn your water heater on and off. We talked about the boiler, the thermostat. This is my generator panel. This happened to have a room thermostat. Yeah. Now this is your office, Adam, calling for heat. Look what happened. So here's Adam's office right here, calling for heat. And now when this is closed, look what happened. The relay is energized, guys. We'll close this contact. Now let's go to the water. The water, guys, there's a water pump. I'm going to show just the water here. The water starts going all the way to a radiator and comes back to the pump. Remember, we're pumping water here. This is hot water going to Adam's office. This is cold water coming to the boiler. Can you guys see that? Hot water going to Adam's office. Throw all this heat into his office. The water gets cold. It pulls back into the boiler. Remember, this is going also through the boiler. All this is going through the boiler. It gets hot again and keeps circulating it. That's how they send hot water to heat a building. Any comments, any questions, guys? Comments, questions? Heat a building. So that's my hot water. Okay, Shad. We talked about the, I don't know if you can see, Karen, look at that group of elements fused at 70 amps. This is a huge load, guys, electrical load. So look at that one. They've used them at 70 amps. All these are 70 amp fuse, 70 amp fuse. So they can individually control all these heating elements. Individually control and protect. So if this heating element shorted, if this is too short, the only one that's going to blow up is this fuse. So the rest of the heating element will continue to work. So what do? You do it to a maintenance. You put it in a maintenance schedule and you go fix them. Okay, so that's this is how they did the control in this building. This is probably the most important thing, wiring method. Look what happened, guys. They take a 20 amp circuit here, They take it all the way, um, feed a relay here to a relay. Out of the relay, they bring it back through the pipe into the pump. And that's how they control the pump. And the thermostat here will control this relay. So the thermostat will be located in that particular room, occupancy, controlling that relay here. When it turns on, hot water comes. And how is your hot water coming is from here. Here's your office right here. The hot water comes, circulates, goes back. That's the cycle of your water. Any comments, any questions? And Adam, they have how many of them? 5 of them. Why 5 of them? 5 occupants. Why didn't we do it this way in our project? Anybody can tell me why? How many occupants do we have? 1 occupant. We don't care about. It's all controlled. The air handling unit that you guys have designed, it will throw the air in the whole building based on a couple of thermostats strategically located in the building that controls it. A couple of on-off switches, guys. Here's your thermostat. This is the temperature. This is a timer. That could be a timer. You bring your wire here. I don't know if you guys can see. Here's a common conductor coming in. Normally open, normally close contacts. Normally open, normally close contacts. So you can do 4 control out of this relay. 4 control out of this relay. So this is a relay with 4 controls that you can do out of it. With normally open, normally close. This is your circulating pump, big boy, circulating water. And that's basically all what I want to emphasize here. Any comments, guys? Any questions? Any comments? Any questions? Adam, when I was green years ago, it used to drive me nuts, the whole heating and cooling. When I worked at Elliott Beckett, I went to a mechanical engineer, sat with him and said, could you please explain to me how does a chiller and a boiler and an air handling unit and an exhaust fan interface with each other to make a heating cooling system? This is coming, guys, and next project we will have speaker to talk about the heating cooling. Heating cooling of a building, heating cooling ventilation of a building is a huge load. We're not mechanicals, but we need to understand it. So that's one step of understanding how to cool and heat a building. Electrically speaking, guys, we're interested in powering the equipment. And if you end up working for one of the mechanical guys, you might be the control guy who pull all these wires too. So just be aware that heating and cooling of a building, you're looking at to heat and cool a building. If you're doing electrical, to heat and definitely, well, not definitely, and most likely electrical to cool. If you heat and cool a building, you're looking at 30% of your load, atom, is going to be dedicated to heating and cooling a building and ventilating it. So it's so important, guys, to understand heating and cooling. There was a few chapters coming that talks about heating and cooling a building in this semester and next semester, because 30% of your work, Karen, in an engineering firm or electrical contractor firm will be related to heating and cooling a building. From an air handling unit to chiller to cooling tower to boilers to pumps, circulating pumps, into exhaust fans and what's not. Any comments, guys? Any questions? Comments, questions? Okay, so what I'm going to do, guys, I'm going to walk you individually. Maybe we'll start with, I'm going to start with Derek. I'll walk you through how to lay out your lighting circuits. And
I did that before. I was going to get through it.
The emergency circuits, did you do that? Yeah, we'll drop an emergency circuit in one location, and we do a circuit with you, and Karen will do the same thing. Adam, for you, are you done with your outside lighting yet? Or are you going to be working on it?
I mean, I don't know what else.
Oh.
Visual, what we did with whoever that was.
Yeah, you're going to go finish it. I don't know where you, I'll look at it where you are. Let me look at it. Okay, thank you.